Hello everyone, I'm 物理所硕一的李宗启，学号是 R11222061, and my topic today is going to introduce some principle or application about the modern maglev chains. So first, we have to introduce the name or meaning of maglev, and maglev is the combination of magnetic and levitation, which means that if there is something with maglev, it can move without friction, noise, and if it can move without friction, then it costs less energy than the transportation, like a normal train or normal other vehicles. So it is also environmental friendly. And next, I want to introduce the history of the maglev chains. The research has begun in 1902. The first magnetic chain is invented by Alfred Zenden in Germany. And in 1959, the design for the first magnetic chain was created. Next, in 1979, first magnetic chain was built in Hamburg, and Germany but was closed. But the chain in Germany was closed a month later, and with some mysterious reason, I don't know. And in 1984, the first chain the people could ride was built in Birmingham and in England. And there are I have listed some research about maglev chains according to their generation, and you can see that the speed of the maglev change has been an outbreak along with the years going. And next, I want to talk about the basic principle of maglev change. The maglev chain have to perform the following functions to operate at high speed. The first is levitation, and the second is propulsion, and the final one is guidance. And you can see the what's it work to the chain on the pictures. Propulsion, levitation, so the force is up, and the guidance is to keep the chain in the trail and not to derail. Then first, I want to introduce magnetic levitation. Magnetic levitation, which is maglev, is a method by which an object is suspended with no support other than the magnetic field. So the one of the example about the magnetic levitation about semiconductor is on the right picture. So you can see that there are no touch between the two magnetic, and because for the not semiconductor is superconductors, and for superconductor we have to lower the temperature to a value, so the characteristics of the superconductor can be revealed. And magnetic force is used to counteract the effect of the gravitation force, mainly in this application. There are two most important parts involved in maglev, and the first one is lifting force. It provides an upward force sufficient to counteract the gravity. And the second is stability. It ensures that the system doesn't spontaneously slide or flip into a configuration where the lift is neutralized. And what is lift? According to different magnetic fields or magnetic dipoles, the materials in the system will press each other together and or apart. We must define the magnetic pressure on the chain from the amount of lift or gravity. For example, the magnetic pressure of a magnetic field on a superconductor can be demonstrated as the left hand side of the equation is the pressure of the magnetic force, and which is the force per unit area, and the right hand side is the square of the magnetic field divides the permeability of the vacuum. And let's talk about stability. Using only paramagnetic materials such as ferromagnetic iron, it is impossible for a static system to stably levitate against gravity. In some cases, the lifting force is provided by magnetic, but stability is provided by mechanical support, which constrains the two magnets along a single axis, like, for example, a rod, and this is termed two-store levitation. And there are two types of stability. The first is static stability. Static stability means that any small displacement away from a stable equilibrium causes a net force to push it back to the equilibrium point. And magnetic materials are used to provide static stability for usual. And the second is dynamic stability. Dynamic stability occurs when the levitation system is able to damp out any vibration-like motion that may exist. And it is provided by adding current damping, which is conductive metal influenced by field and the tube mass dampers in the levitated object. And next part I want to introduce maglev technologies. There are two types. The first is electromagnetic suspension, which is EMS. And it means that the chain is the system is electronically controlled electromagnetic in the chain checked into a magnetically conductive check. The check is usually made of steel. And the second is electrodynamic suspension, which is EDS. And in the system, we use superconducting electromagnetics or strong permanent magnets that create a magnetic field, which induces currents in nearby metallic conductors when there is relative movement, which pushes and pulls the chain toward the designed levitation position on the diode. And in EMS, the chain levitates above a steel rail while electromagnets attached to the chain are oriented toward the rail from below by the stator and the support magnets. The rail is situated between the upper and the lower edge of the undercarriage. Magnetic attraction varies inversely with the cube of the system, so minor changes in distance between the magnets and the rail produce greatly varying forces. And maintaining a constant distance from the check by a gap sensor, and the distance is approximately 15 millimeters. And this is the picture and the principle of the gap sensor, and you can review it. Okay, and let's come to EDS. In EDS, both the gateway and the chain exert a magnetic field, and the chain is levitated by the repulsive and attractive force between these magnetic fields. The repulsive and attractive force in the check is created by an induced field in wires or other conducting strips in the check. At low speed, the current induced in the coils and the resultant magnetic flux is not enough to support the whole chain. Therefore, the chain must have wheel or some other form of landing gear. And the coil like 8 is what is the configuration of the coil in the check for EDS. And there are the merits and the demerits of EMS and EDS. And I think the EMS is most suitable for people to use because the magnetic field in it is very low. But the EDS is the magnetic field in EDS is too strong to let people getting it. And let's come to the proportion. The principle of proportion is opposite poles attract each other and like poles repel each other. And major components of the system are a large electrical power source, metal coils that line the entire guide wire, and the final is guidance magnets used for alignment. And how it works. First, stators of the maglev system are usually in the guide rails. Next, rotors are located within the electromagnetic system of the chain, and the alternative current allows a pull from the magnetic field in front of the chain and a push from the magnetic field behind the chain. When the alternating current is reversed and the chain breaks. So different speeds are achieved by varying the intensity of the current, and only the section of track where the chain is traveling is electrified. So the rest, the left hand side is the principle of propulsion to the chain. You can see the net force is where the chain is going to or is braked, and the curve is how the current or the magnetic field travel. Okay, and I have listed some comparison between the magnetic chain and the conventional chain, and obviously we can see that the cost of the magnetic chain is higher for sure, and but it is environmental friendly and costs less energy and less noise, of course, and it have higher speed. Another application for magnet I want to introduce is NASA plans to use magnet for launching space vehicles into low Earth orbits. And Boeing is pursuing research in magnet to provide a hypersonic ground test facility for Air Force. And the final is the mining industry may also benefit from magnet because the materials needed and the transportation. And my conclusion is more energy efficient and environmentally friendly than present-day railway system, which is the modern magnet technology wish to do. And magnet will have a positive impact on sustainability. The final is magnet trains are the future of the transportation world. Thank you for listening.